Here's a chemical, there's a chemical, everywhere's a chemical.
Hey there! Coach Powers here with ChemCoach. Today I'm going to be introducing a new segment, and it's called Everyday Chemistry. So this is the first, the initial, the inaugural Everyday Chemistry segment. And this is just going to be one of these segments where I can give you a video every once in a while about something that we might find in our house that we want to know a little bit more about. And this could be anything that you are excited about. Leave a comment, let me know what you want to know about, and I can do a little research and make it a part of this segment. And if I do that, you're famous. I mean, that's just all there is to it. You'll have all 49 of my subscribers having your information. It's going to be more than 49 eventually. All right, so everyday chemistry, you guys are going to love this. Today we're going to start out with something that I had referred to in a previous episode, and it was one that I said was very important because it was like a hand sanitizer when no hand sanitizer seemed to be around. Remember it? Brut. Brut, brah. Is it Brut? Brut. And if you look here, you can see the ingredients. Number one ingredient there, denatured alcohol. Okay, so we're going to do a little experiment. Because of course we know in everyday chemistry, we want to know if it burns. Burn, baby, burn! Because, you know, I've been teaching chemistry for many years, and that is the number one question in all of our minds is, does it burn and how well does it burn? So, we're going to find out. We're going to see if this really does have maybe about 50% alcohol, because you know when I go online and I look at Brut's website, nada. So, we're going to have to do a little experimentation to figure it out. So, I hope you're going to have fun. Hope you stick with us to see about whether or not Brut burns. Okay, so, what's up? First thing we're going to do is we're going to just try to take some 95% ethyl alcohol so we can have a basis for comparison. And we're going to light that and see if that burns. Yes, it does. Alright, so we've got our alcohol burning. You'll notice our scientific chemistry equipment here is everyday chemistry, so we can use everyday equipment like the lid of a pan. Alright, now we want to see what happens if we put the alcohol on it. This is the Brut. Okay, now I have not tested this yet, so this is the first time I'm seeing this happen along with you. So I have no idea what's going to happen. Let's just find out. Look at that. Oh my goodness. Alright, so that is burning some pretty solid flame there. Let's look at the lights go out. Oh yeah, good lighting. Now you notice there's a little bit of residue that is being left behind, and that's because that Brut has some things in there for the moisturizers, for lotion and things like that. It's an aftershave after all, so it's supposed to make the skin feel a little bit better as well. Alright, I will come back here in just a second. So now what I'm going to do is I'm going to get a little bit of water. This is just tap water. I'm going to put about 10 drops. 1, 2, 3. And then we're going to take some alcohol, and we'll do 11 drops of that as well. 9, 10, 11. Okay, so the reason we did that is so that we could see if a 50% alcohol in a 50% water solution would actually ignite. Now remember, that's 95% alcohol, so we're not actually at a 50-50 solution here. But look at the size of that flame. Very, very, very small. Okay, so there's alcohol in there that's getting burned, but it's not nearly as much as what we saw before. That indicates that that Brut is probably pretty powerful. Alright, so we're going to do that same thing with the Brut now and see what happens. And then we're going to go into the Brut. Okay, so we're just getting right into that Brut. And pull out a sample of that, and we'll do 11 drops of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright. And now, we'll ignite that and see what it burns like. Oh, come on. Ah, okay. So it's not burning. So that indicates that that Brut is not as, you can see it kind of gets an extra little bit of a flame, so it's got some vapor that it's burning there. It doesn't, oh, there it is. It's going a little bit. You see it? So it took a little bit, probably indicating that it has less alcohol in it than that 95% alcohol, right? All right. All right, so we're doing another little experiment with our Brut. I was about to set a little secondary experiment up, and I thought, oops, I made a mistake. And so now I'm going to do what I normally do with alcohol, permanent marker. I'm going to see if Brut will take off my permanent marker like alcohol does. Ooh, not bad, not bad. Let's see if the alcohol does better. Yep, alcohol definitely wins the permanent marker removal test. Alright, so I'll be back and I'll show you the next thing. Alright, so what we're doing now is we're just going to do a test of 1, 2, 3, 4, 5, 6, 7, 8, 9. The test of the alcohol, 1, 2, 3, 4, 5, 6, 7, 8. To see where we might get to that point where it's no longer going to be flammable. Is it at the 40% mark, the 46% mark? I've done this before and I think it's actually closer to the 30% mark, but let's just check it out and see. More opportunity to burn things. Right, let's do one more little experiment here. I have a feeling that this one is going to have one of them that does not burn. If maybe even both of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 H2O. Over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 H2O. And we'll go to alcohol. Now it's really fun to look at what happens when these guys actually interact. When you see the alcohol hit the water, you see an interesting effect. And that effect is caused by the alcohol molecules and the water molecules interacting with each other. We're going to do 4. 1, 2, 3, 4. It's actually kind of violent if you look at it closely. It pushes them around pretty quickly. We got a little flame over there on that 33% one. One of the things to think about as far as another variable that could be affecting it is the fact that I started with the 26.7%. So while I was doing all this, you know, this was having a chance to evaporate, which could also affect a little bit. But definitely saw that we didn't have enough to burn there. Had enough to just barely burn there. So it gives you a little bit of a feeling for what the percentage needs to be to actually burn ethyl alcohol, which is probably around that 30%, but it doesn't burn long, and it definitely doesn't do a good job for that. So one more time, let's just have a little burning party. The Brut's over here on this side, and alcohol's on that side. And let's do a little side-by-side comparison. You can see the alcohol definitely seems to be burning bigger. And the Brut's got a good strong flame though. Definitely have high percentage of alcohol in the Brut. So I would obviously conclude that Brut probably could be used for a hand sanitizer. Alright, so that was a lot of fun. Always fun to burn things. It's our first example of doing everyday chemistry. And this is, Brut has not paid me anything. If you would like to, Brut, I would love to take some money from you for promotional purposes. Obviously, they're not going to advertise themselves as a hand sanitizer because they haven't gone through and had all that stuff tested. They would probably have to go through the FDA and make sure that they'd killed certain germs and things like that. But I think we can at least make a good conclusion here that it is very likely that Brut would do just as good of a job as a lot of the other types of alcohol-based products that are out there, the hand sanitizers that you're using. So, hey, go to the store, buy some Brut if you're looking for a way to get some quick hand sanitizer. Definitely has a strong odor. You either like it or you hate it, I think. So maybe sniff a little bit of it first before you before you buy it if you're really offended by certain smells. I think I smell amazing. Thanks for hanging out with me for Everyday Chemistry. This is ChemCoach Powers signing off for today.
Here's a chemical, there's a chemical, everywhere's a chemical.